Good day, guys. We'll be looking at a particular software that is referred to as Gaussian. Now, I believe we can all see Gaussian on my screen. Gaussian is a software that we use to compute or that we use to make quantum calculations and ab initio, that is, we use them for quantum calculations, especially ab initio calculations. Not only that, we can also use it to carry out molecular mechanics calculation as well as semi-empirical calculations. So, but basically, quantum chemists used this software to carry out electronic nonlinear optical calculations, and frequency calculations, various spectroscopic calculations, and so many other things. Now, that is it about the software I have here. Although you have different upgrades or different versions of Gaussian, you have Gaussian 09, you have Gaussian 16, and lots more. So, but before we discuss about the functionality of Gaussian, let's take a look at this particular software, its graphical user interface that is called Gaussview. So before we discuss or we can discuss anything about the Gaussian software, we are going to look at Gaussview. Now, as we can see the screen, let's follow up together. Now, as you can see, the software is opened, and as you can see, this is a graphical user interface. And this is an empty space. This is a working space where I can input in my particular whatever I want to model for. I can place it from this particular spot that we have here into those particular spots here, as we can see the cursor, into this particular empty space. So this is Gaussview 6.0. As we can see, we have, let me walk you around this particular software. We have files, we have edit, we have tools, we have builders, we have view, we have calculate, we have results, we have windows, and then we have help. Each of these this particular operators that we have here, maybe call them operators, they have different functionalities. They have different functions. So take for instance, the file has a new molecule group, you have add molecule group A, then you have open. I can decide to, like, let's say I have modeled a particular very big compound on, let's say, software like ChemDraw, and I want to import it. I can just click on this open button. Once I do that, locate where the file is by the working directory I must have created and import it into this particular empty space. To then ask me some questions like, do you want to show the bonds and the hydrogens? Then I click on yes, and then it pops up. But there is a rule into this. Any file that must be imported from any external file that must be imported to Gaussview must be an SDF file. It must be an SDF file. So we can see we have recent files. You can look at this has been the work I've done. Yeah. Then related files, then fresh, save template files, convert, directory, print, save images. These are all the functionalities that could be annexed to files. Now let's take a look at edit. Now this is the edit button. We have the undo, we have the redo, and these are shortcuts. You can see these are shortcuts, or these are ways we can maneuver coming or moving our cursor down here to, like, maybe undo or redo. So you can, instead of moving your cursor down, you can just make or do you can just access these things by clicking on your keyboard, Ctrl plus Z to undo and Ctrl plus Y to redo, then the Ctrl plus X to cut. Say I want to cut off a molecule, I can cut it off and paste it in a new working directory. I can also copy using Ctrl plus C. I can access that Yeah, the reason why I can't access any of this particular button, sorry, is because I haven't yet placed anything in this particular working space. I haven't yet placed the working space is empty, so I can't click, I can't do any operation, I can't perform any operation on these guys. So you have the paste, you have the delete, you have the image, and lots more. But something is quite getting interesting. If I decide to close these guys, you would observe that each of these functionalities that I have mentioned now, like take a look at this, you can see that these functionalities are all the sub functionalities are present here. Like, can you see this is cut, copy, oh, paste, wow, delete, okay, undo, right, redo, then rebond, and lots more. I think that should be, can we, yeah, so can you see you have rebond? Wow, rebond 2 is also there. Then you have remove weak bond that is present, clean, mirror invert. You can see all of these functionalities, sub functionalities are present in this particular ribbon. How interesting. So we can come to tools too. You can see the continuation of these of what we have on the ribbon on the left far right hand side. Can you see the atom list editor, the doctor coordinate editor, connection editor, and layer selection tools. We all have them at our at the tip of our fingers here. Then we can come to the builder. The builder, here we have the element fragment. As you can see, okay, is there any relationship between this guy here and this guy here? Okay, yes, there's a relationship. As you can see, this is a shortcut towards coming towards builder and trying to access this. So instead of me coming to builder to come and select on the fragment, I can just come here directly to click on this guy and I have access to it. The reason why it is highlighted is because of I am on this particular, I have selected this particular operator. I've selected this particular guy here to carry out the operation. So imagine if I click on the ring, you see it, I will end up with the benzene, and then if I come to tools, I mean builders, we see something like what ring fragment, the cursor or the highlighted blue, the blue cursor, the blue thing that represents the highlighting is on the ring fragment. So same thing goes with if I click on this guy, you see that it would be on the R group fragment and so on and so forth. We can view the viewing. As you can see, we have hard view, we have the center. The center is to centralize any atom that I place here. If I want to bring the atom to the center, I can click on the center to centralize the atom. If I want to, if I don't want to show the hydrogens, then I can do away with that. I can click, I can uncheck where I have the hydrogens. If I want to uncheck the labels, I can uncheck that too as well. But what would be funny is that whenever I paste them here, whenever I bring anything that I have here into this particular empty space, this is our working space here, I'm going to have I'm just going to have maybe carbon and no label. Can you see? So it gets interesting. So in order to avoid that, I can come back to the view, then reselect the hydrogens, and let's come back and reselect the labels. So it gets quite interesting. So we have the Cartesian axis, I mean the synchronized Cartesian axis, the stereochemistry, and the positioning tools. All are all accessible under what? Under the view description. Now we can calculate. This is where Gaussian overlaps with Gaussview. We can make some quantum calculations. Can you see Gaussian calculation setup? If I want to set up my calculations for Gaussian, if I want to get to be an overlap between Gaussian and Gaussview, I just come to the calculate, then I select the Gaussian calculation setup. We are coming back here, then we'll take a look at the Gaussian quick launch. This is also part of this is a functionality, a sub functionality that is attached towards the operation or the operator calculate. Then we have the Gaussian calculation scheme. We have the GMMX conformal dialog, AMPAC calculation setup, AMPAC quick launch, AMPAC calculation scheme, current jobs, and SC job managers. So, and so many other things. The result, if I want to view the result of my calculations, anything that I've done for, I can come here to check out on those things. Okay, it is NMR calculations. I will come out to check my NMR result, UV visible to construct the spectrum, or RD, optical rotation dispersion, the Brunic, so many other things. I can check them on this software. Windows, I can minimize, I can restore, I can close, and so many other things in this software. So that is that about the introductory aspect about this particular ribbon that we have here. You can see the reason why it has written, you can see there's a tetrahedral here. Why has it written tetrahedral? This carbon tetrahedral is connected towards this particular structure that is down here. If I choose benzene now, for instance, we see it will change. The name has changed to what? To benzene. Reason being that what it is telling me that I have a benzene in this particular place. This, if I'm to paste any molecule here now, for instance, I will see a benzene. That's not what I want. Let's say, for instance, I want to place in, or I want to form a tin molecule. Now, how do I form that? I can just come here, place my compound. Okay, we can see this is ethylene. And mind you, whenever we want to join the other carbon, because a thing is a combination of two molecules of, let me say, if I join two methane molecules, I'm going to get an ethene, like, but there's meant to be a carbon to carbon bond. Never make the mistake of selecting the hydrogen here and then coming here to select this. This is not an ethane molecule. This is typical chemical suicide, because this is not looking ethene at all. There is a bridge, or there is an hydrogen that is being sandwiched by two of these methyl group, which makes no sense. So in order to avoid that error, don't select on the atoms that are outside any of the hydrogens. Since it is the carbon you want to connect, since the carbon to carbon bond, select on this carbon and then you bring it here. Okay, we can see that we have an ethane molecule. Now, if I want to centralize, where do we come to again? I think that should be view, and then we click on center. Wow, our molecule is already centralized. It's at the center now. And then I can do anything I wish. The molecule, I can zoom in, I can zoom out, I can rotate, I can move it anywhere I want to move it to. All right, guys, thank you for having